Alright, so there's four types of radiation. The first type is known as a beta particle, also known as beta decay. Alright, and this is when an atom has too many neutrons. So you can see here we have carbon, it has an atomic mass of 14, it has 6 protons in the nucleus, or an atomic number of 6. So if we do the math, atomic mass minus the number of protons, that tells us that this right now has 8 neutrons. Once it goes through its beta decay, that's what this arrow is right here, okay, that arrow represents beta decay, it will then change. Notice its mass doesn't change, it's still 14, but its number of protons will go from 6 to 7. Okay, so its number of protons actually went up. And that's because, if we do the math here, 14 minus 7, that tells us that we only have 7 neutrons in the nucleus now. So what is beta decay really all about? Well, it's essentially a neutron turning into a proton. Okay, and how does it do that? Well, neutrons have a charge of 0, right? Or you can think of a charge of 0 as being a combination of a positive and a negative, right? And if you give off your negative, or you get rid of your negative, that charge of 0, or that neutral charge, becomes positive. So that's exactly what happens here. Our neutron gets rid of a negative charge and becomes a proton, making the ratio more balanced or more stable. What does that mean? Well, it means that the beta particle, which is what we're referring to here, okay, the beta particle that's given off, has a mass of 0, a charge of -1. The symbol we use is an E because the only thing that we know of that has a mass of 0 with a charge of -1 is an electron. Okay, so charge of -1, mass of 0, it's a fast-moving electron. So these electrons are going to be spit at high energy off of the radioactive substance. They'll hit anything they come in the path of. Turns out they have moderate tissue penetration. So if you're sitting around this stuff, it's going to go through your skin, it's going to go into your body, and it turns out the only way you're going to shield it is with aluminum foil or wood or anything more dense than these substances. It's all about density. So as the electron hits these substances, it will slow down and stop. But if you're only wearing clothing and you're not like wrapping yourself in aluminum foil like armor or something, then this would go right through clothing. Okay? So that's beta decay. That's our first type of radiation. Now let's look at our next type of radiation. Next type of radiation is another type of beta decay. However, we call it positron decay, okay, or beta positive. So you can hear it either way. It's either beta positive, or you could call it positron decay. And the reason why it's so similar to beta decay is it turns out that the particle that it gives off, the positron that it gives off, has a mass of 0. Okay, now positron decay happens when you have too few neutrons. So normal beta decay was too many neutrons. This is too few. Notice here we start off with an unstable form of boron. As it goes through decay, the mass stays the same, but the number of protons, or the atomic number, goes from 5 to 4. Okay, this is the opposite of normal beta decay. So normal beta decay was a neutron turning into a proton. This time we're taking a proton and we're turning it into a neutron. Essentially think of it as you have this particle, it has a positive charge. If it gets rid of its positive charge, it will be left with a charge of 0, a neutral charge. Okay, and so what happens? Well, the mass stays the same, but our proton changes into a neutron, so our atomic number goes down, which means the substance turns into beryllium, and the particle that's spit out, essentially the radiation particle that's given off, has a mass of 0 and a charge of +1. So it's kind of like an electron, but it has a positive charge. So instead of calling it an electron, we call it a positron, because it's a positive electron. So it's a positively charged electron. It shoots off just like that highly energized electron that we saw before. It has moderate tissue penetration, so it's going to go through skin. And again, you're only going to be able to shield it with things that are as dense or denser than aluminum or wood. Okay, so that's our second type of radiation. Now let's go on to our third type of radiation, which is known as alpha radiation. Notice the symbol for alpha is kind of like a fish. Okay, beta, we didn't look at that before, but it's a bee with a little tail. Okay, so alpha decay, or alpha particles, call this alpha decay, happens when an atom is just too heavy. Okay, look at this. Uranium is massive. It has a mass of 238. Okay, it's just too big. Too many protons, too many neutrons, and so it's simply going to just give off some of its mass. Alright, notice that uranium here is going to turn into thorium. The mass goes down 4 units, and the atomic number also goes down. This is different from beta. In beta, there was no mass change, right? But the atomic number did change. Atomic number changed by 1. In alpha decay, the mass changes by 4 and the atomic number changes by 2. So alpha is really easy to spot because you see this really big change in atomic number and atomic mass. Okay? And so that mass has to go somewhere. So if this goes down by 4, that means that our alpha particle has a mass of 4. Okay, so this right here is our alpha particle. Has a mass of 4, and it carries with it 2 protons that left the nucleus, because the nucleus went from 92 protons to 90 protons. So if it has a mass of 4, the only thing that could have come out of the nucleus were protons and neutrons. So this right here is made up of 2 neutrons and 2 protons. What do we call that? That's a helium atom. It's not really an atom as much as it is a helium nuclei. It's not an atom until it picks up its 2 electrons, but it is the nucleus of a helium atom. Okay? It turns out because this has so much mass, when it hits an object, it's going to like bounce off, or it's going to slow down. Okay? And so because of that, alpha particles have low tissue penetration. They're going to hit your skin. They can probably penetrate a little bit, but they're not going to go deep down into like the bones. Okay? And it turns out that you can actually shield yourself from alpha particles using paper or clothing, okay, or anything denser. So aluminum and wood would stop alpha particles. You need at the very least paper or clothing to protect you from alpha particles. Okay, now let's talk about the fourth and final type of radiation, the most dangerous type of radiation that we're going to talk about. It's known as gamma radiation or gamma decay. And notice that the symbol for gamma decay is kind of like a Y. So it's like that. Okay, and this happens when an atom has too much energy in it. So it just needs to bleed off energy. And it actually turns out that a lot of the time when you go through gamma decay, you also go through beta decay or alpha decay along with it. So gamma, like one type of radiation isn't necessarily going to be the only type of radiation that a substance gives off. Uranium may give off beta particles as well as gamma particles, that sort of thing. Okay. The thing about gamma decay is it's also easy to spot because it doesn't change the atomic number or the mass. Gamma rays have a charge of 0 and a mass of 0. They are simply just pure energy. Okay? It has too much energy, so therefore it's just going to give off some of that energy. It is a high energy photon. What's a photon? It's light. Okay? So this is extremely energized particles of energy that are given off by the radioactive substance, and they have high tissue penetration. That's why gamma rays are the most dangerous of them all, everything we're talking about here. And it turns out that it can only be partially shielded by concrete, lead, or anything denser. Okay, so gamma rays are bad, and pretty much the only way you're going to protect yourself from gamma rays is to basically go underground, under concrete, put a lot of material in between you and the radioactive substance. So that's why nuclear fallout shelters are under dirt, under concrete, under lead, under steel, with enough stuff so that those gamma rays can't get into that bunker that those fallout shelters form. Okay, so that's the fourth type of radiation. Again, it's probably the easiest to spot because it does not change the charge or the mass of the substance. So what does this all mean? Well, it turns out math is going to make a return. It makes a comeback. Yes, we got to do some math.